All right, I believe we should be live. Let me check the stream. Everything looking good. Yes, perfect. Welcome to another episode of Hoot. We'll be talking about Envoy and rate limits. We have a lot to talk about today, so we'll get packing. We are back in the solo offices today in Cambridge, Massachusetts. Massachusetts is opening up. So we're back in the office. I'm doing this in a slightly different setup, so I'll be looking out for the chat. Feel free to drop your question as I talk. Every few slides, I'll go back to the screen to see if there's any questions. Okay, so let's start talking about Envoy and rate limiting. This is an audience requested topic, so let us know if there's any question. It here. Sometimes that page is a bit laggy. All right, so without further ado, let's begin. We do these hoots every couple of weeks, and this is also a new microphone. So if there's any audio issues, please let me know. From what I'm seeing, it looks like fine, but feel free to tell me otherwise. And let me just check that nobody said anything. Okay, I think we're good. All right. We do these episodes every few weeks. We kind of try to spread the knowledge. If you have any suggestions, there's a link to suggest an episode in the description. So go ahead and do that. Subscribe, like, share per usual to help this content reach more people, educate more people. All right, so let's talk about Envoy and rate limiting. We'll even prepared a little agenda here. Let me make a slideshow. So just let me make sure that the slides are visible. I think they are. Yes, perfect. Okay, yeah, it's a new setup today because I'm in the office, so learning the ropes here. So okay, first we're going to do an introduction. What does it mean? What alternatives we have for different use cases, right? You might actually not want to use rate limiting for your use case, how it works, the architecture, the components, how configurations, scaling considerations, and we'll do a demo, of course. All right, so let's start with an introduction. What and why is global rate limiting? So the motivation that we usually see is either business driven or operationally driven, right? So either you have a business need to limit rate, right? To say this IP address, for every IP address, I only want 5 requests per second, right? And then obviously when we say rate limiting, we mean limiting the rate of requests that Envoy proxy processes, right? If you're new to Envoy, you can we have a whole series on Hoot explaining the Envoy from the start. I'm assuming people already know what Envoy is, so I'm not going to go there. So a business use case, you don't want a certain user to go above a certain rate, API plans, that kind of thing. And there are operational use cases where, let's say, you have a database that have relatively small number of hosts, and you don't want your entire distributed system, your entire cluster, to overwhelm the database. So you want to account, globally the access to that database, right? So that's kind of the motivation of why global rate limit is useful. Let me just see if there's questions. Okay, we're good. All right, now, before I go into how this rate limit is implemented, how a truly global rate limit system is architected here with Envoy and the rate limit server, let's talk a bit about different approaches in Envoy. So first we have local rate limits, right? It's essentially a token bucket system, limits incoming requests. Now, it's not global, right? Each instance of Envoy has its own token bucket and its own rate limit view of the system, right? So it's good if you want to limit the rate, but it's not so good if you want to limit the global rate of your entire fleet to a certain instance, right? So that's the local rate limit. There's a filter in Envoy that can do that. It's good if you want to control load, if you have a predictable number of envoys. It might work for your use case instead of the more sophisticated global rate limit. So the local rate limit apply on incoming requests, right? Besides that, we have a circuit breaking mechanism in Envoy, and that applies to outgoing requests. So the goal of circuit breaking is to limit the load Envoy generates on upstreams, right? So you can say to Envoy, if you have this many active requests, stop sending new ones because clearly the upstream is not keeping up with the load, right? So that's circuit breakers. There's various things you can tune there. I'm not going to go into the details on this talk, but you can active requests, pending requests, retries. You can read the documentation, and if you like, put a suggestion. We can, if we see there's demand, we can do an episode of Hoot for that. In addition, a relatively newer addition to Envoy is adaptive concurrency, which you can think of it as essentially dynamically setting the circuit breaker values. Currently, the circuit breaker are a constant number, 1,000 requests, right? So adaptive concurrency allows you to adaptively change kind of in response to measured load, the concurrency limits. All right, so these are all alternatives to global rate limiting. And the global rate limiting means that we have a global rate limit across all, all our clusters. Oh, and I see I obviously have a signature typo. This is Envoy. Sorry about that. All right. So, here we go. So what is the problem with Envoy and global rate limiting? Obviously, the problem is that Envoy doesn't have any state. It's meant to be dynamically, scaled up, scaled down, used as a sidecar. It doesn't have its own state, right? In addition, Envoy is distributed, so even if you try to distribute the rate limit into the various Envoy, you'll have a hard time synchronizing between them because of, distributed systems are always eventually consistent. Right, so how do we solve that? We introduce a component to hold the state and have Envoy query that component to achieve a truly global rate limit, right? So we create a rate limit service that Envoy will query and ask if I should be rate limited right now, and based on that answer, Envoy will either rate limit or allow the request. Right, so far so good. So the way it's architected in Envoy, there's a rate limit service, and the official rate limit service from Envoy is a stateless service, and it stores its state in a Redis or a cluster Redis. We'll discuss this a bit later, right? And the way it works, the rate limit service is a gRPC interface, right? You have a gRPC protocol definition, and you can implement your own rate limit server, right? The one provided by Envoy in github.com, Envoy proxy / rate limit, this is what I'm talking about in this Hoot, right? And that server is stateless and stored its state in Redis, or memcached now was recently added. So far so good. I know I'm talking fast, so let me see if anybody's asking anything. So far so good. All right. So next, let's talk about the configuration model. And this is the thing I noticed that get really confusing to people, right? So, and I'm going to talk about it a bit, and then in the demo, I'm going to review the YAML so you see how it looks in action. So the way a rate limit is modeled in Envoy is something called descriptors. And each descriptor has a descriptor entry, right? And there's an action that generates a descriptor entry, right? So a descriptor entry is essentially a property of the request, right? Not necessarily of the request, but a certain property that you want to have the descriptor to have as part of the rate limit decision, right? So you specify a bunch of actions. These actions generate descriptor entries, and if they don't generate a descriptor entry, then the whole descriptor is not generated. And the end result of that is an ordered list of these descriptor entries, and that's the descriptor. right? And each descriptor represents a logical operation, right? And Envoy sends to the rate limit server one or more descriptors and asks the rate limit server, should these descriptors be rate limited? And if one of them it needs to be rate limited, then Envoy declares this request over limit and limits it, right? And all the other descriptors, even if they're not rate limited, they're still counted towards the limit, right? So if you have two descriptors, one with one request per second and another with two requests per second, and you send a should rate limit request with these two descriptors, both of those counters will reduce by one. All right, so far so good. This is how Envoy looks at things, and you'll see in a second in the YAML, we'll have an entry in the route, and you'll see these actions and how they generate the descriptor from the actions. We're going to show it also how the server receives them. Hopefully it'll be, I know it's not clear by now, but hopefully it'll be clear by then. All right, so the configuration model on the server configuration essentially specifies a tree that matches the descriptors sent from Envoy. And again, I'm not so super clear now. Hopefully it'll be clear when I get to the demo. So let's say Envoy sends a descriptor, and that, as we said, the descriptor has a shape of an ordered list of descriptor entries. The configuration in the server needs to match that ordered list. So if Envoy sends a descriptor with 3 descriptor entries, the server configuration, the tree depth, will also need to be 3 to match the shape of the descriptor sent by Envoy, right? Each descriptor entry has a key and a value, and also the keys and potentially the values also need to match together in the server configuration tree. And I'll show those configurations side by side so it makes sense. If the server cannot match, then it does not consider this something that needs to be rate limited on, so it's important to get this right. All right, some notes before we go to a live demo. By default, if rate limit query fails or times out, the request is allowed, and you can change that default. There's a default mode in the filter settings. And the rate limit filter also emit metrics. You can see them attached to the cluster. You see rate limit. The cluster name .rate limit .ok .error deny on fail. And we'll also take a look at those in a sec. So just as far as observability, you probably want to watch out to see if the error count increases, things of that nature. All right, so far so good. As far as scaling, right, we talked about Envoy. Envoy is stateless. You can scale it up or down as much as you want. Rate limit service is stateless. You can scale it up as much as you want. You can even couple it as a sidecar to Envoy if you want. Let's talk about Redis, right? So Redis natively has a method of supporting scaling out, and it's called cluster mode. And you can use that. The way you use that is you actually send the rate limit service through its own sidecar Envoy, and that way you can use Envoy's Redis cluster abilities, right? The alternative would be to implement it inside the rate limit service, which I don't think is implemented as of today, but feel free to correct me if I'm wrong here. These things change pretty fast, right? So you can have Envoy calling the rate limit service, and then the rate limit service has currently, a bunch of Redises it can call to. But if you want to do something more sophisticated, you can actually have the rate limit service call an Envoy sidecar to re-leverage Envoy Redis features, right? So one of them is supporting Redis cluster mode. The other one is client-side sharding. And with client-side sharding, you can have a bunch of Redis in a Redis cluster, and they're all not configured in cluster mode. They're just simple Redis instances, and they are unaware of each other. And Envoy can actually take the rate limiting keys and do kind of like a consistent hashing, right? Do like maglev load balancing, and always send the same keys to the same Redis, right? So if the Redis cluster doesn't change much in size or doesn't change frequently in size, that works because Envoy will route the request to the correct Redis instance, right? The disadvantage being that data is lost anytime a cluster that changes in topology, right? Because the thing is rehashed. Or rather, part of the data is lost. Depends, how you do it. And that could be fine, if your use case is limiting scale, let's say in a resolution by the second, it might be okay that, you might lose a second in the state, So it really depends on your use case if you're okay with that or not. Now, another option that we're not going to show but still going to talk about is having a separate Redis cluster for the per second limits, right? So a rate limit is usually 1 per second, 1 per minute, X per unit of time. So 2 per hour, 1 per second, 1 per minute. So the rate limit service by Envoy can actually use a separate Redis for the per second limits. So you can actually scale that cluster independently because there's obviously a lot more activity, in the per second one. All right. So with that, let me see if there's any questions. I know I talk a lot and I know I talk fast. So far, we're looking good. Let me check that other one. All right. Okay, with that, let's go into talking about the demo. Let me exit this and go to VS Code. Perfect. So now I've prepared a few configurations, and I'll show this is here the rate limit configuration, and we'll show it side by side with the Envoy configuration. So let's start with the filter configuration, and then we'll move on to the route configuration. So, one sec, here we go. So we have here the filter configuration. You can see we have the name, we have the typed config. The main important part here is the rate limit service. We set it to a gRPC service with a cluster, and the domain. Now, I didn't talk about the domain up until now because it's not that important. It's mainly a means to kind of do multi-tenancy. The server will match a configuration based on the domain. So this domain needs to match the domain in the server configuration, and the server can have multiple configurations with different domains, right? So this is how the filter is configured. The main takeaway, you just got to set the domain correctly and got to set the service correctly. And that's basically that. And after the Hoot, I will push everything to GitHub. So you will have it, available. All right. Now, let's talk about the filter versus the route versus the server configuration. So these are the routes that I have. I have two routes, one to /resources and one to just to /. And you can see I define rate limits on these routes. Oh, sorry, here we go. So the resources has 3 set of actions. Each of these actions translates to a descriptor entry. So each of this translates into a descriptor. Right, so this is a descriptor, this is a descriptor, this is a descriptor. The order of the descriptors doesn't matter, but the order of the actions does matter. Right, so remember we talked about an ordered list. This order here matters, but the order among the different actions doesn't matter. All right, and the /one has a very simple, generic key, remote address, single descriptor, single rate limit, pretty simple. Now let's see how this matches up with the server configuration. So the server configuration, if you recall, I mentioned it's kind of like a tree. So you have the top level, and each level can have a sub-level. Right, so let's just talk about a simple case for one, which is a single level configuration. So if you remember, we have the descriptor. each descriptor has an ordered list of descriptor entry. Each descriptor entry is a key and a value, right? So the server configuration matches, and let me just check that I'm not talking too fast, that everybody's happy. So far, so good. All right. So the server configuration matches that, right? So you can see here key value, and so here there's another level, and potentially another level. I actually want to talk about this one. This is the single level one, right? So I have here key value. So this means you have a descriptor. We match this part of the configuration tree if the key is generic key and the value is resources, right? And then we have a rate limit of 1 per second, right? Okay, now in this scenario, not only I have this one level with a rate limit, I also descend and have another level, right? So if instead of just one descriptor entry in the descriptor, I have two descriptor entries, then we will descend to the next level. And if the descriptor entry, the second descriptor entry key is named header match, and the second descriptor entry value is named post request, we're going to end up in this section of the configuration tree, and the limit will be 10 per minute. Right, and let's talk about this first one here for a second, just kind of get the full picture. So again, we have this vector, right? And maybe I'll just write out here kind of how it looks like. Envoy, what Envoy sends us is the ordered list of descriptor as the entry. Each descriptor entry is a key and a value, right? So we have key 1, value 1, key 2, value 2, etc. Right? So in our case, if Envoy sends us a descriptor that is generic key, right? And the value is client, we will go to this section of the configuration, right? If the key is generic key, but the value is resources, we'll go to this section of the configuration, right? So let's say we got generic key and client. Then now we're going to this section of the configuration. Notice that this generic key client does not have its own rate limit, which means that we cannot terminate here. If we terminate here, it's not a valid thing to limit on, and it's not going to rate limit. All right, so in this case, if generic key and client is sent, then we have to also have a second descriptor entry with the name of remote address. Now you'll notice that there's no value here, but there are rate limits. And what that means that essentially it's kind of like put in value of star. It means apply this limit for every unique value. So this configuration will do a 1 per second limit for every unique remote address. So every unique IP gets its own 1 second rate limit. Right? I could have written a value here, and then it would be specifically to this value, to that remote address, and all other remote address would have been ignored and not limited. All right, so hopefully this makes sense. So let's just see how this all matches, lines up nicely. So let's first start in this one, in the second route. You can see that I first have here generic key with descriptor client. So this matches this, right? It'll get here. Now, as I said, there has to be another one if we have the generic key and client, because this one doesn't have any rate limit. So you can see I also tell Envoy to send the remote address, and there's no configuration here because Envoy automatically knows the remote address. You need to configure some things for Envoy to know that, but let's not talk about that right now. So it'll get to this second part, and Envoy will provide the remote address of the client as it sees it. Let me check if there's any questions. All right, header value match is mapped to header match key automatically. Yes, that is correct. And the way you know this is you go to the Envoy docs, and you go, I have it somewhere here. Here we go. Sorry, no, not this one. Here we go. So you go to the docs, right? You see that I did header value match. You go to header value match. You click this, blah, blah, blah. The descriptor entry is appended as following. See header match, descriptor value. So that's how you know. Other options, obviously, look at the source code, and another option is to run everything in debug mode, which I will demonstrate in a second. Hopefully this answered the question, Arish. Let me know if you have any follow-ups. So yes, header value match automatically gets sent with the key header match. So each action generates, it could generate a key that's predefined name by the code. It can also, some of them accept the key name and allow it and set the value. So you got to read the docs to know exactly how the key and value match from the action to the descriptor entry. And if you really want, Envoy allows you to actually extend this and add your own capabilities here. And it has a built one that uses cell to really get custom properties of the request to rate limit on. Cell is the common expression language from Google. Okay, so now let's talk about that second route. And you can see that we have three sets of descriptors here, right? Now, remember the order between those doesn't matter, but the order inside matters a lot because it must match the configuration tree. So let's see how that works. First descriptor, we have one action with a generic key. That value is resources. And that means this will generate a descriptor with single descriptor entry inside it, and it must match, therefore, this limit, right? We only have one level in the tree here. The second action here, this one, you can see that it has the same generic key as before, resources, but this time I do a header value match, and I only add the post request descriptor value if the method is a post method, right? If it's a post request, right? So this thing will match this one, right? Essentially, I go to the configuration tree. I start with generic tree resources. Good. Header value match generates the key header match. Good. And the descriptor value will match to post request, right? So if I hit this route and the method is post, I will get here and will get 10 per minute. Now, what happens if the request is not post? What if it's a get request? If it's a get request, this header value match will fail to add a descriptor entry, right? The action does not add a descriptor entry, and in this case, this whole descriptor is not generated, right? So this descriptor will only be generated if it's a post request. Right, so if it's not a post request, Envoy will only send 2 descriptors instead of 3. If it is a post request, Envoy will send all the 3 descriptors that I defined in these rate limits. And finally, we have essentially the same one as before, because we still want a rate limit on the remote address for clients. And there's also another way to do that. I'll leave it as an exercise to the user. I can put this action these actions in this descriptor in the virtual host and ask the route to include the descriptors from the virtual host. But you can look at the Envoy config and figure that part out. I want to get to the demo, and let me just see if there's any questions. Where is this chat? Okay, so far so good. All right, now the magic happens. We're going to do a demo. To do the demo, we need the terminal, obviously. And let's make it a bit bigger. Okay, good. Oh, too big, sorry. Okay, just right. Now, let's just start some servers so we can send requests to it. It really doesn't matter what's going on in there. We start Redis because we need Redis to back up the rate limit. Exit, oh, because I already have it running. Let's kill the other one because I don't know what's in there. and start this one. Okay, perfect. Let me start another terminal and split it in two. And on the one side, I will start the rate limit service, and I have here a handy command. And again, I'll put all of this in GitHub for everyone to enjoy. Let me just review this before I run it. So I'm running the Envoy proxy rate limit service, and you can see I export a bunch of environment variables that configure it. Specifically, I tell it to connect to my Redis. I get the log level to debug. I set the gRPC port to a port that Envoy is configured to talk to it. And I set the configuration directory. Oh, one sec. Before I do that, I got to cd to the right folder. Perfect. So, okay, now we run it. Oh, invalid. There's Redis DB somewhere. Sorry about that. Left over. Move it. Let's run. Perfect. So you can see that my rate limits were loaded from here. Also, another thing you can do if you're not sure that they were loaded, you can go, the rate limit has a debug page. Let me go there. And you can see that this is the rate limit server. If I go to its admin page, there's an RL config you can go to. And there you can see that the rate limits were correctly loaded. All right, so this is good. Now we're going to start Envoy. I have here Envoy Glue just because it's a pretty recent Envoy. Ever since the change to v3, you can use upstream Envoy. It's all good. I'm not using anything Glue specific here. And we'll start Envoy with the Envoy config we just reviewed. And obviously, I'm in the wrong folder. Good. Now we really start Envoy. Let me just clear the terminal before I do that. Okay, good. So now Envoy is running. Perfect. Now we can do a bunch of curls. So let's first curl regular localhost. Sorry, what am I curling? What's that? One sec. One sec. The YAML port here. Port is 10,000. That looks good. Why am I getting? Oh, sorry. I'm getting that because that's my Python is listing the directory content. So, okay, that's good. All right. So let's clear the terminal so we can see what's happening. Okay, good. So we send a request to the regular route, right? You can see Envoy called the rate limit server, and the rate limit server got the descriptor. And this is exactly the ordered list that I mentioned that Envoy sends, right? So this is the descriptor, and you can see here key value, comma, key value, right? So Envoy is looking up, seeing what it needs to rate limit. It sees that the rate limit is 1 per second, so it's all good because there's no, it's not over the limit, and we return a normal response. If instead of curl, I use hey to blast it, hey is a utility that just sends a bunch of requests. You can see that I get a more distribution. I get more 429s. I also get 503. Curiously, I assume it's the Ivan app can't handle the load, but we'll explore that in a different time. But you can see that I get some 200s and I get some rate limited, right? And if I'll look at the Envoy stats, what's the Envoy stats? Here we go. So I'll grab the Envoy stats to find rate limited. You can see that we have rate limits on my cluster. I have 100 errors. I have probably maybe a Redis can handle the load on my laptop. We have a bunch of OKs and we have a bunch of over limits. Now remember, in our case, because failure mode is allowed, all the errors will be allowed through. They will not be rate limited. Okay. So over limit is C97. This should match more or less these 97 responses that we saw getting 429. So far, so good. Let's see if there's any questions about what we talked about so far. So if I change the rate limit config value, will it... okay, so that's actually a very good question. Do you need to restart? The answer is no. It also depends how you do it. So if you go to the config rate limit, there's two ways to do it. The old way with the runtime, it involves a symbolic link, and they actually specify exactly here how to do it. Either way, you don't need to restart the rate limit server, but you have two options. You either update a symlink, right? So basically, you prepare your new configuration in a new configuration root folder, and you update this folder as a symlink to a new subdirectory containing all your config, right? So all your config is in runtime subdirectory /config, and you point Envoy to look at the symlink. Right now, you want to update the config. You prepare a new config. Nothing happens, right? Because Envoy doesn't see it. And then you atomically upload the symlink to point to the new config. So that's kind of the way the kind of classic way, I guess. They call it the runtime, and you atomically update all those runtime values. The other option, the one I did on this demo that is simpler for me right now, is to turn on this runtime watch. And then Envoy, you don't need to do all the symlink, you just update the configs in this directory and the rate limit server will watch them. So you can see, for example, if I will update this 1 to 2 and I'll save it. Oh, I should have done it when I should clear my screen and do it. So let's do 3 and save it. You see that it's hard to see, but you'll have to believe me that it reloaded the config because it watched it on disk. And of course, I'll push all this stuff into GitHub so you can also try yourself and see that it works as expected. So the short of it is that you don't need to restart the rate limit service. All right, moving on to the next route in my demo here. Curl with post, and no, we'll leave the post one sec later. So again, clear this. So this time I'm doing resources, right? And you can see we got a descriptor like before, the generic key client and the remote address, but we also got the other descriptor, the generic key resources, right? And if you remember, this is exactly, actually, let me leave this on as reference. This is exactly what we set here, right? So you see the method wasn't post, the header value match didn't produce a descriptor entry, so the whole descriptor was excluded, but this descriptor, the generic key action, did produce a descriptor entry, so it was included, right? So you can see that I got two descriptors, right? So let's get back to the terminal. It's the terminal. Here we go. Oh, didn't mean to open another one. Sorry about that. Here we go. All right, so now let's do a post request. Oh, you know what? Let me clear. And you can ignore the not implemented error. That's fine. So now you see we got, again, the same descriptor as before. But this time, ta-da! We got this descriptor with two descriptor entries, with the generic key and the header match, because it's a post request. And if we scroll down more, we see that we also got that last descriptor that we did get before. Because all of the actions generated descriptor entries, we got all of those descriptors generated and sent upstream. And here is the rest of the logic is Envoy looking to see if it needs to rate limit. And you can see that if we do a bunch of these, we eventually gonna hit, I lost count, but there's 10 a minute, it can be that far. Here we go. So as you can see, rate limit remaining 0, too many requests, and in about a minute it will reset. All right, I hope it all makes sense because I know it can get confusing. Let me see if there's any more questions. So far, so good. I hope this was useful. Again, I'm going to upload everything to GitHub so you'll have it as a reference. Let me just summarize what we talked about. Maybe I'll go into the slide agenda. So we talked about an intro, a little bit global rate limiting. I assume most people here know what the meaning is of global rate limiting, and that is to limit a rate in a global way consistently across the cluster, right? So we talked a little bit about alternatives. It really depends on your use case. You may not need global rate limiting. If you don't need it, it's just easier not to use it, honestly, right? Because you do need, because global rate limiting requires state, and state is always harder to manage. Right, so we talked a bit about the architecture. We have Envoy, we have the rate limit server, both open source, GitHub, Envoy proxy, and then you have Envoy and rate limit. The rate limit service, because it is stateless, it needs to be backed by Redis or memcached to store the actual state, to store the actual counters, because otherwise you couldn't get a global rate limit, right? This only works because every Envoy in the cluster effectively asks the rate limit service that asks Redis to the current counter. So Redis knows to increment those counters and can give you a truly global rate limit. We talked a little bit about the configuration, how it's modeled. At Envoy, it's modeled as descriptors. Each descriptors have a list of actions, and each action generates a descriptor entry. A descriptor entry is a key and a value. So we end up with an ordered list of descriptor entries, right? So we have one or more descriptors, and each descriptor has an ordered list of keys and values, the descriptor entries, and this list is a match to the configuration tree of the server, right? So the server has the configuration kind of looking like a tree. You start from the top, see does this descriptor entry in this descriptor Envoy send matches this configuration in the top of the tree. If yes, we go to that branch of the configuration and descend. Now we compare the second level of the tree and the second descriptor entry, right? So that way we go until we are finished looking at all the descriptor entries in the descriptor Envoy send us, and if in the end of that we reach a configuration section that has rate limits defined, then we rate limit. So this is kind of how the configuration works. We talk a little bit about observability. You can look at the Envoy stats to observe errors, to observe when rate limit happened, and observe when it was okay, when it wasn't rate limiting. We talked a little bit about scaling, that you can use client-side sharding as a really simple way to scale out your Redis, because one Redis instance cannot hold it all. And the way you do that, you can, the most simple way to do that is attach an Envoy sidecar to the rate limit service and have Envoy do the client-side sharding, because Envoys already have advanced Redis proxying capabilities, and it can do client-side sharding for you. So you can kind of get it for free. And in the end, we did a little demo showing all these configuration YAMLs in practice, hopefully to get the understanding a bit more grounded. All right, so let me just check in for any final questions. If there are no any more questions, I will wrap it up for today. Thank you everybody for joining. We will see you again in 2 weeks with another episode of Hoot covering and educating things cloud native. Please feel free to propose topics. To do that, you just go here, GitHub, solo.io, Hoot, bam, easy peasy. Issues, new issue, episode suggestion. I see we have a new one from 38 minutes ago. Thank you. I will look at this right after we wrap up here. And that's kind of give us an idea of what you all want to see. I see someone, one question, yes, but what is the question? Rich, feel free to ask. And of course, if you see in the episode suggestion thing that you like, just do the thumbs up. You don't need to open another one because they'll confuse us. While Harish, you type in your question, is Redis mandatory? Either Redis or Memcached. So the rate limit server does not have its own state. Oh, for custom, no. If you, so, okay, let me actually go over that. It's very important. Envoy doesn't care about Redis, right? Envoy, blah, 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 right? As far as Envoy is concerned, rate limit is a gRPC service. Envoy doesn't know if there's Redis and doesn't care, right? So if we look at the protobuf, all Envoy cares about is that you have a rate limit gRPC service that has a should rate limit function that takes a rate limit request and returns a rate limit response, right? And in fact, in previous Hoots, specifically the one about external services, you can see a dumb server that I've implemented. Let me open it up here. That does not use Redis. So let's open this silly server. You can see it in the GitHub. And I have here like a server that implements a bunch of Envoy services. One of them is should rate limit. And just make this bigger. And that's all you need to implement a rate limit service. Whoops, what happened? Okay. And in this case, the rate limit servers always return okay, so there's no rate limit, right? All the Redis stuff, that's the responsibility of the rate limit service. That's up to the rate limit service, right? And in addition, the rate limit service can be configured to actually use a local cache for over limit requests. So it's kind of optimized to not have to go to Redis all the time for every request. So you can look at the docs and see if that's of interest to you. But yeah, you don't have to have Redis. It's not a requirement by Envoy, it's a requirement by the rate limit service. And yeah, this is essentially all you need. Like you can, this is a rate limit server, right? With all, not exactly the most sophisticated one, but the working one that Envoy will talk to. Is MemoryDB a good option? So, assuming you mean an in-memory DB like Redis, or do you mean a specific product in mind? Oh, my suggestion. So, the way they do it, in-memory DB is generally not a good idea because it doesn't scale, right? If you want to scale up, you got to use a technique like a client-side sharding. The reason it works, this in-memory cache, the reason it works is because they only do it for over-limit requests, right? They don't record in the cache requests that have not yet been limited. So once you are over the limit, it kind of doesn't matter anymore until the time window is over, right? So let's say you have 10 requests per minute, and after 10 seconds you hit all the 10 requests, then you know for in the next minute, assuming the clocks are reasonably synchronized, Redis will tell you no anyway, so you can cache that part locally, but only the over limit request, right? The problem with H2 is it is in memory. Once you reach capacity, you don't have a way to scale it up for another instance. Whereas with the Redis solution, you can use client-side sharding, for example, or Redis in cluster mode to scale out Redis. That said, if your use case is not that complicated, if you don't expect a high load and you think a single instance can deal with it, then yeah, why not? You don't need to overcomplicate things. If they don't need overcomplicating. If H2 is fine. You can start with that, and once you outgrow it, move to the Redis implementation. I hope that answers the question. Was the Slack? For some reason started annoying. Okay, I hope that answers the question. I'm glad you find it useful. And if you have any questions, I'll be looking at this page. Leave a comment with your question. I'll look at the comments for the next few days in this page. So let me know what you're thinking. If you have any questions, follow-ups. If you have episode suggestions, again, the better place is in the Hoot repo. That way everybody can see it. And with that, I'll wrap it up for today. Thank you, everybody, for joining me, and we will see you in about 2 weeks. Goodbye, everyone.